Selamat datang Bapak Ibu di webinar Altium. Untuk hari ini kita akan membahas sedikit tentang apa yang baru di Altium Designer 21, Better Way to Design. Perkenalkan, nama saya Budi Wong dari PT SolidBase Technology, Reseller atau distributor untuk produk Altium Designer di Indonesia. Oke, untuk hari ini kita akan membahas 4 fitur yang baru. Banyak juga improvement dari Altium-nya, yaitu simulasi spice simulation untuk mendefinisikan rigid flex design, terus kemampuan high speed design capability, dan improvisasi skematik atau schematic improvement. Oke, untuk simulasi spice ini bagi Bapak Ibu yang sudah pernah memakai Altium dari versi yang cukup lama gitu ya, dari Altium Designer 2006 itu sudah ada spice model. Tapi memang untuk spice model yang ada sekarang di Altium Designer 21 ini sudah mempunyai engine yang agak baru. Sudah mereka improve. Oke. Untuk simulasi ini sudah sangat mudah, step by step-nya juga sudah dimudahkan, user interface-nya juga lebih baik. Simulation error identification analysis-nya juga sudah lebih baik. Jadi kalau misalkan ada yang error di simulasinya akan ditampilkan pesan yang lebih user friendly dan dapat dibaca dengan lebih baik. Oke, di Altium Designer 21 ini juga sudah ada LT Spice Importer. Jadi kita punya lebih banyak opsi untuk melakukan simulasi. Dan juga kalau kita tidak ada modelnya, Altium itu di library-nya sudah ada ready to use sim model. Jadi kita tidak usah takut misalkan seperti resistor, kapasitor, komponen pasif dan sebagainya, itu sudah ada spice modelnya. Jadi nanti kita tinggal mengambilnya dari generate komponen, nanti kita tinggal setting parameternya, kapasitannya berapa, resistansinya berapa. Setelah itu kita rangkai dan kita jalankan simulasinya. Oke, ini contoh ada beberapa simulasi. Dari segi tampilan menjadi lebih baik karena tampilan panel-panel yang sudah lebih user friendly. Terus untuk simulation kita sudah ditempatkan di satu panel yang sama gitu kan. Jadi untuk source, probe, analisis dan resultnya kita bisa langsung dilihat di panel. Oke, kelebihan dari simulasi ini adalah mengurangi testing secara fisik. Jadi kalau misalkan dalam tahap R&D, research dan development, kita cenderung akan sering melakukan adjustment atau fine tuning ya. Jadi dari kita punya skematik, misalkan kita mau seperti misalkan kita ada filter, kita mau filter sinyal untuk menjadi lebih baik, kita tentunya harus akan mengubah banyak nilai atau menambahkan komponen. Jadi kalau misalkan nanti ketika kita melakukan simulasi, kita bisa lakukan dengan mengubah nilai-nilai komponen atau menambahkan komponen langsung di skematik tanpa harus membuat PCB-nya atau menyoldernya langsung dulu. Dan ini sangat menghemat waktu, dan baiknya itu di Altium sudah ada langsung di satu software, yaitu ada di skematiknya. Dan ketika skematiknya sudah sempurna sesuai dengan hasil yang kita mau, misalkan dari rangkaian filter itu, nanti kita tinggal tambahkan komponen footprint ke setiap komponen di library skematik, dan akhirnya nanti kita tinggal convert aja ke PCB. Itu akan menjadi lebih baik dan menghemat waktu. Oke, terus setelah kita membuat skematik, tentunya kita harus tahu hasilnya. Nah, untuk melihat hasil itu, mereview hasil dari simulasi itu kita ada di panelnya, dan kita bisa simpan juga hasil sebelumnya. Jadi misalkan kita jalankan simulasi yang pertama dengan nilai resistansi misalkan 100 kilo atau 100 kilo ohms ya. Setelah itu kita mau ubah nilai, misalkan kalau resistansinya kita ganti misalkan 1 kilo ohms. Nah, nanti hasil dari dua testing ini, dua running test simulation ini, kita bisa bandingkan dan kita bisa lihat hasilnya. Oke, untuk modelnya kita bisa lihat di sini di library, kita tinggal search saja, atau misalkan kalau kita sudah ada model untuk komponen tertentu, ya kita bisa impor aja seperti yang tadi saya bilang, dia sudah ada LT-Spice importer juga. Oke, untuk library-nya sudah support banyak tipe ya, dan analog P-Spice juga, LT-Spice, Digital Spice itu sudah di support. Jadi jangan lupa ketika kita bikin simbol library di Altium, di skematik, ketika kita bikin, kita nanti tinggal mendefinisikan filenya, file spice-nya, kita import ke komponen tersebut. Setelah itu nanti kita tinggal tentukan kakinya, kaki pinnya. Jadi misalkan pin 1 itu untuk input, atau misalkan anoda, atau misalkan untuk kasus ini misalkan di dioda ya. Dioda itu misalkan kaki input dan anoda dan katodanya seperti itu. Setelah kita definisikan, tentunya akan kita pakai nanti di skematik kita ya. Setelah itu nanti kita tinggal hubungkan, nanti kita bisa ubah parameter untuk misalkan resistansi, kapasitans, dan sebagainya. Untuk yang generic model itu kita sudah ada ya, semua rata-rata di komponen Altium ya, di library. Jadi biasanya generic model itu misalkan seperti komponen pasif, resistor, kapasitor, induktor, transistor juga ada gitu ya. Jadi kita tinggal pakai aja, nanti kita tinggal ubah nilainya, parameter di properti di komponennya tersebut. Oke, untuk demonstrasi simulasi desain di Altium, kita akan memutarkan video untuk mengetahui lebih lanjut bagaimana cara step by step simulasi skematik tersebut.
Okay, we've now switched to Altium Designer. I have here open a Hartley oscillator project. This schematic here is going to be used for simulation. So you can see here, I'm going to open up the simulation dashboard. You can go to simulation dashboard to open it up. So as we talked about, the simulation dashboard allows you to have a guided setup. We're going to start here with the verification of the design. So as soon as we do that, it does an electrical rule check and it checks for all your simulation models. As you see here, we are missing models for everything, but as we mentioned, you have the ability to apply generic models. So you see here, it says, would you like to auto assign models? So I can simply click assign and update the verification, and we see that all of the models have been added except for J2. So we can simply click add model, and it's going to pop up here, and you see that you have the option to get models from your server, local files. We mentioned the .lib files, so we'll be doing that next. You have generic models, and you can actually click Octopart as well and browse through the collection of components here in Octopart, and anything that has models, you can actually select it. But we're not going to do that today. As I mentioned, the .lib, we have this local. So I'm going to do browse. It showed up on my other screen. As I mentioned, this is a P-Spice library that is being read in. We have all of the simulation models. We'll go into more detail about this in a little bit. So I'm going to select right here, and you see the information is filled in. The pin model information is synchronized here, and when we go to the model file, we see the model here Since it is a library file, you can see a lot of models here. We also see the format types. We have Mixim, LT Spice, P Spice. And as I mentioned, that will be growing in the coming months to support more digital models. As of right now, we support mostly analog models. So now that we have added a model, we're going to click OK, and we see once again, we update the verification. Anytime there is a change, you must run the verification again. So we come over to the preparation section. As we talked about, you have all of your sources in one area. You can add more sources. You can add probes as you see fit through here. From here, we're not going to actually add anything today. But you see here, you have the 4 different simulation types. Each simulation type allows you to actually have different setup conditions, as you can see. We also separated things such as Monte Carlo simulation, since that is essentially used to supplement these types of simulations. So I'm going to start off by running the operating point. Right, and you see here it starts running it. But when we actually go back, what you can see is the voltage, right? Because I said display on schematic voltage across the entire design here. As we run through the other simulations, you can do DC sweep, come back, transient, and lastly, AC sweep. So you have all of those results. As you see here, the results can be once again clicked on, and they will open up once again. So let's say you need to make some changes and rerun the analysis so you can kind of see the differences. If you look here, you can see show results, load profile, or delete the results if you would like. For the next section, what I'm going to show is, we mentioned the .lib files. So if I open up the components panel, we can see all of our component definitions that are in our workspace. But if we come down, I have the local .lib file. So we have all of these defined here automatically based on the models from the PSpice library. And what we see here is if you actually start making if you place it from the models, it will automatically generate a symbol for you. So we're working on, making the symbols a little bit more realistic and usable. So in the future, this type of symbol will look more like this. And we'll do that by kind of recognizing the type of components. But for now, you have this type of symbol available to you.
Oke, setelah kita melihat simulasi SPICE di Altium, selanjutnya topik kedua kita akan membahas tentang definisi berbagai desain rigid flex di PCB. Jadi misalkan kita mau mendesain sebuah PCB yang agak kompleks dengan ruang desain yang sedikit kecil gitu ya. Jadi kita mau memanfaatkan beberapa ruangnya dengan menggunakan rigid flex. Nah, rigid flex ini sebenarnya sudah ada di Altium sebelumnya dan sudah banyak improvementnya juga. Tapi di Altium Designer 21 ini sangat improvementnya sangat banyak sekali ya. Jadi kita bisa mendefinisikan individual substack region. Jadi misalkan kita punya beberapa wilayah, misalkan satu PCB board kita mau definisikan secara individu. Terus kita bisa overlap juga untuk setiap regionnya. Jadi misalkan contoh gambar yang di sebelah kanan ini, di bagian bawah kita mendefinisikan satu persatu ruangannya. Terus untuk boot bindingnya juga kita bisa definisikan. Folding inside cutout, jadi misalkan nanti di bagian rigid atau flex PCB-nya kita ada cutout, kita juga bisa definisikan di situ. Terus independent bending line, jadi setiap flexible PCB-nya itu nanti kita bisa definisikan juga bending line-nya seperti apa. Oke, untuk materialnya kita bisa definisikan ya, apakah mau yang agak rigid, terus yang adhesive dan sebagainya kita bisa lakukan di layer stack manager seperti ini. Oke, untuk demonstrasi kita akan memutarkan juga video bagaimana cara mendefinisikan layer stack dan sebagainya.
We're going to start off with a stiffener design. You can see here I switched to board planning mode. As I mentioned earlier, the board planning is divided by regions now, or defined by regions. So you see the individual regions here defined. You can have overlap between the regions, and that is determined by priority, which you can see right here. We'll go into a little bit more detail there in a little bit. One nice thing that has been added is because of these independent regions, you can now utilize snapping. You can see right here that in order to get the two edges to meet up, you see the little snapping icon right there, that little circle. So if I want to make it flush, it's really easy to make it flush. So let's go into a little bit more detail in the layer stack manager. I can press DK and open that up. We see here R2 with, we named it R2 plus stiffener. If you click this new add functionality, you can see I can add the stiffener or adhesives. So here I'm going to add a stiffener, and you can see that it is added into the layer stack right there. In addition, you can see if you haven't worked too much with this new layer stack document type that was introduced a couple of releases ago, you see that in the properties panel, you can do stuff like define whether the area is a flex area or not. Coming back here, we now have this new layer stack associated here, R2 plus stiffener. If I want to change the color of any region, I simply click here, and it gives me a better visibility of the board overall. I mentioned that if you have a realistic stack up, it's a little bit easier to convey design intent. So here we have a draftsman document of this PCB documents. You could see here all of the different layer stacks available for us, and it'd be really easy for someone to be able to read this and understand the differences between the different layer stacks. Moving on to another design here, we have been talking about the overlapping regions and how that is defined by priority. So if I click here, you see that there are many regions. I'm going to select region F5, which is encompassed by this area here and this little curve. And you can see that I have associated layer stack F5. It has priority 0. We can see over here some more priorities. And the way that this is defined, if a higher priority means that it will take precedent over the other ones. If they are at the same priority level, the stack up with the most number of layers will win out. So coming through here, we have the bend lines. As we talked about, these are now persistent. So if you make any edits to the board shape, you are still able to see these bend lines. They will stay there, and then you can move them over, associate them to the required area. Here in the properties panel, you can define which stack regions are utilizing this bending line. So we see here, we just have F7. For another one over here, we would have F6, and so on. The different regions are really easy to identify in that manner. If we switch over to 2D, we see the whole design with these connectors. We come over to 3D, And as I move this over here, I can hit 5 and it will show us the fully flexed board. We see here there are the overlapping regions and the bend lines as they are defined by region type. Even though these are overlapping, we were very easily able to associate the bend line to the different layers and have this split. One more design we have here. We have this region defined within another region. So this whole, the big region is R1. And you can see here the layer stack is rigid, priority 0. And then when we click again, we can select F3. And we see that this is actually a flexible layer stack. Because it has priority 5, that will have a higher priority than the original rigid layers, which are priority 0. We see the same thing in areas like over here. We can see the different regions. And what's nice is being able to see the different definitions really quickly defined, and I can change these individual shapes if I need to, right? Let's say I need to make this longer or shorter, and it's not going to destroy these bending lines. That's one of the things that was really difficult to deal with before. When you were defining rigid flex designs, the bending lines would disappear when you change the shape. So that's no longer an issue. If we switch over to a 3D view, and once again, press 5 to flex the design. We'll zoom out a little bit, and you see here the area that is overlapped is flex, and we have the cutout here that perfectly cuts out the remaining area of the zone. So we defined a square here within the big rectangle, and then the cutouts to just define that specific area. So I'll flex it once again, and we see over here we have certain materials that split up based on the stacks we've defined, and you can see in certain areas the defined rigid and the flexible area. So if I actually flatten this out again, you see this rigid and then this flat area. When I flatten it out, you're actually able to tell in the layer stack you have the rigid area and then you have the flexible area. So by working with the priorities in the properties panel, you're able to define shapes that would have been incredibly difficult to define in the past, and very easily define them and work with the different types of layer stacks. We also looked at adding the adhesives in the layer stack manager. So let's go back to the slides.
Oke, topik ketiga yang akan kita bahas di webinar Altium ini juga adalah high speed design capability. Jadi yang sudah seperti kita tahu ya, di versi-versi Altium sebelumnya kita sudah Altium itu punya namanya length tuning. Nah, length tuning ini fungsinya untuk men-tune atau meng-adjust panjang track ketika kita mau melakukan desain di high speed. Jadi misalkan analoginya, kalau misalkan kita di jalan raya, misalkan kita mau dari titik A ke titik B, kita ada 2 jalur. Jalur pertama lebih panjang dari jalur kedua. Nah, otomatis nanti kita dengan kecepatan yang sama, otomatis di jalur 2 kendaraan atau sinyal yang berjalan di jalur itu akan lebih cepat sampai di titik kedua. Kenapa? Karena jalurnya lebih pendek. Nah, sama dengan di high speed design ini, jadi ketika kita mempunyai beberapa jalur yang kita mau kirim sinyal secara bersamaan, kita usahakan panjang jalur ini sebisa mungkin sama panjang di jalur PCB-nya ini. Oke, di length tuning ini kita juga bisa melakukan namanya single length tuning, yaitu cuma satu track aja. Misalkan tadi yang track 1 dan 2, jadi kalau misalkan yang pertama lebih panjang, yang harus kita tune itu adalah yang lebih pendek. Jadi jalur kedua yang perlu kita tuning. Nah, kita tuning itu kita ada beberapa patternnya, jadi nanti kita bisa pilih. Dan juga misalkan kita juga bisa melakukan tuning juga untuk differential pair dan bus routing ya. Jadi bus routing ini misalkan kita punya 8 jalur data ya. Nah, tapi 8 jalur data ini panjangnya misalkan kita karena kondisi PCB-nya sempit dan sebagainya atau kecil, jadi kita routingnya juga susah ya. Nah, solusinya kalau misalkan kita ada satu jalur yang lebih pendek dari jalur-jalur yang lain, kita bisa melakukan yang namanya length tuning tersebut. Oke, seperti yang tadi saya sebutkan juga, kita bisa melakukan single line tuning, kita bisa melakukan untuk differential pair, dan yang ketiga itu kita bisa melakukan juga untuk bus routing ya. Nah, kalau untuk yang di differential pair, ini kita bisa langsung tuning aja dari tracknya tersebut. Oke, tentunya sebelum kita melakukan length tuning, kita mau melakukan setup di design rule-nya. Jadi design rule-nya itu misalkan kita setup clearance-nya dan sebagainya, agar ketika kita melakukan tuning, dia tuningnya itu meletakkan pattern tuning itu sesuai dengan peraturan yang kita setup. Jadi misalkan clearance-nya kita mau 20 atau 30 mil misalkan seperti itu. Oke, untuk demonstrasinya kita akan memutarkan video juga tentang bagaimana melakukan optimasi fine tuning atau length tuning di Altium.
Let's see here. We have the mini PC project. I've made a couple of changes to it with some different design rules. So we're going to start off by making sure the properties panel is open. It's really important to use the properties panel while tuning. So the first thing we're going to do is we're going to come down here to the bottom of this VGA, and we see a lot of single-ended traces here. This will be a good area to start showing some of the new tuning. You can see up here in the active bar, you have two types of tuning. You have interactive length tuning and differential pair tuning. So of course, right now we're working with single-ended traces. So we're going to click here, and you could see creating the tuning sleeve very quickly. I'm going to create it like that. And you could automatically start seeing some of the changes here. We have the accordion. As I mentioned, there are different options available now. We're going to start off by moving this around just to see the new changes to the glossing engine. The changes began to be implemented in 8020. And they are further improved now. So we can see you can actually modify the boundaries as you see fits here. Let's say you want to rotate. This is one of the biggest differences here. You can hold the control key and actually rotate the full boundary. As we're working through this, you can hit 3 and 4, right, to make the changes to the width in between, and this has been possible for many years, but just in case you weren't aware of that, 3, 4. There we go. So in addition to that, if you hit space, it's going to change the style, which you can see down here. We can make those changes as need be. and it will automatically change. But again, while you're dragging it, if you hit space, it will automatically make those changes. So I'm going to delete that pattern, and we will switch over to trombone tuning. I mentioned earlier that trombone tuning is pretty similar. The major difference here, if I hit tab, I can come over here without changing the environment. So I'm going to hit trombone. The major difference here between accordion and trombone is spacing situations. A lot of times you're going to want to, generally you would be using the accordion functionality, but let's say you have limited space, like right here. You can see here the accordion tuning is very similar, but it will allow us to better utilize our space here. Let me just create that right there. We can move it to one side if we would like to. See here, moving from one side to the other. And once again, I'm going to hit tab to come over here. And I'm going to do single side. So this allows it to force the system to only use one side. So you can see left or right. And we come over here. It will very easily go around the corners and automatically follow that. We can change the boundaries as we see fit. If we want to make this a little bit bigger or a little bit smaller, we have that capability. And this single side is really important because it helps you control exactly how you do this length tuning. So lastly, we are going to look here at Sawtooth. So I'm going to make just a couple changes. I'm going to make the angle 70 degrees. I'll make this 154, and I'm going to make the actual height 1 millimeter. Once again, we have the single-sided option, and you can do fixed size if you would like. So I'm going to start off with the single-sided option. And you see here, we can go around some corners if we would like. And the fact that we're single-sided just kind of makes it a little bit easier to see the sawtooth pattern right here along the edge. This is going to be pretty helpful throughout your design process. Some people like to synchronize the sawtooth with the fibers of their design. So that is something that is possible now because you can make this whatever angle necessary for your design. So now that we have this placed here, we are going to add a couple more. We're going to come over here and switch over to trombone tuning. And we add it here. And then lastly, we are going to add one last tuning for the accordion. So you can see them kind of interacting with each other, making sure that they optimize the space with each other. And since you can move them independently, as I believe I mentioned earlier, these are called tuning sleeves. You can see how they interact with each other and they allow you to fully optimize the space here. You still have the ability to drag things over as need be to make things a little bit easier to fully utilize the space of your board. So we're going to leave those there, and we're going to look at some differential pairs. All of the tuning capabilities available for single-ended are available for differential pairs. So we're going to start off by selecting this trace right here. And you could see I'm selecting the inside trace. However, it is keeping them coupled together. So, and this is going to go across these vias, and it's going to keep those together. You still have the push and shove capabilities, as you can see here, but you have that ability to stay coupled. So if we come to the properties panel here, you see in this corner the keep coupled. I can disable that if I would like. And now when I move it, it just moves one at a time. Of course, that's not always ideal, but in the situation where you need to separate them a little bit, you have that functionality. And of course, if you're selecting the outside because of the push functionality of the glossing engine, you will see that it will push over the left one. Okay, from here, we will look at interactive routing for differential pairs. It's the same concept, of course, but with the added functionality of coupling, you are able to better utilize these different tuning patterns. So we see here, I can move it down. As I mentioned, you can hit Control and rotate it. And you'll notice how fluid this is because of these glossing engine changes. It's really easy to move these tunes around. With previous releases, it was a little bit more cumbersome, but now that we have these glossing engine improvements introduced in Altium Designer 20, it's just going to keep getting advancing every single year. So we will look at some of the different tunings. First, we had accordion. I'm using short keys U, P for the differences, hitting the trombone tuning. We have that. And of course, if you would like, you can combine them along the same trace. And you see here with these accordions, it's really nice that you have it's coupled and it's symmetrical, right? One thing we mentioned is the entry and exit of pads is now guaranteed to be symmetrical with this keep coupled functionality that I mentioned in the properties panel. So you can see that the tuning sleeves come in and they interact with each other, so you don't step in on each other's territory. So you can see both of them here.
Oke, untuk topik terakhir hari ini, di webinar hari ini, kita mau membahas tentang schematic improvement di Altium Designer 21. Oke, dari sini kita mempunyai intelligent schematic insight. Jadi kita mau melihat dan modify net properties itu, kita sudah tinggal hover aja mouse kita ke titik tertentu yang mau kita ubah netnya ya. Setelah itu kita tinggal ubah. Terus net details juga sudah lebih baik. Kenapa? Karena kita bisa melihat langsung details netnya tanpa kita harus double klik dan sebagainya. Terus untuk logical dan physical net name-nya juga sudah diatur lebih baik, sudah lebih jelas. Page reference untuk offsheet konektornya juga sudah lebih baik. Jadi seperti contoh yang digambar di sebelah kanan, itu misalkan USB 3 itu connect ke mana dan sebagainya, itu nanti sudah terlihat lebih jelas. Oke, untuk genre komponen, nomor manufakturnya sudah lebih baik juga. Kita bisa link juga ke Altium Library Live-nya ya. Oke, untuk parametrik komponen juga sudah diatur lebih baik. Unique symbol untuk memudahkan kita lebih baik ketika kita mau melakukan quick prototyping. Jadi misalkan kita ambil beberapa komponen dari library live ya, misalkan dari Altium, kita mau mengacu ke DigiKey dan sebagainya, itu nanti kita parameter-parameternya bisa kita ambil juga langsung di Altium. Dan parameter ini nanti kita bisa gabungkan ke dalam BOM ya, Bill of Material. Nah, dari Bill of Material ini kita bisa melakukan quick prototyping. Misalkan kita mau bikin 2 PCB board, dan ketika kita bilang mau bikin 2 PCB board, kita harus mengetahui BOM-nya berapa komponen yang harus kita beli, harga estimasi per komponen itu nanti akan ada di komponen parameternya itu, dan kita bisa compile dan akhirnya kita keluarkan di BOM atau Bill of Material. Terus untuk komponennya juga kita bisa replace secara keseluruhan, secara bersamaan ya. Jadi improvementnya sudah banyak di schematic juga. Oke, pin-to-pin mapping ini juga sudah sangat baik. Jadi ketika kita bikin library untuk schematic dan kita link mau ke footprint untuk yang PCB-nya, jadi kita bisa melihat di panelnya, kita tinggal pilih, kita tinggal klik dan sebagainya. Terus kita juga bisa melakukan pin to single atau multiple paths. Jadi misalkan satu pin merepresentasikan path di komponen footprint itu beberapa. Jadi kalau dulu kan point to point ya, misalkan satu ke satu gitu kan. Nah sekarang kita bisa satu ke banyak seperti itu. Terus sudah mudah easy synchronization, jadi sudah gampang kita mau melakukan sinkronisasi antara schematic dan PCB ketika kita bikin footprint atau bikin library. Terus pin dan part swapping, jadi misalkan untuk khususnya komponen FPGA, jadi bisa misalkan kita melakukan pin swapping atau part swapping ya, jadi di schematic ke PCB-nya itu sangat mudah sekali. Oke, untuk demonya kita akan melakukan memutarkan video juga untuk melihat bagaimana improvement di schematic di Altium Designer 21.
We're going to start with the Kame FMU project and the CPU schematic. We're going to look right here. You see this label. It indicates that it should be the name of this wire. However, sometimes it could be difficult to follow when you have a lot of different nets. If I hover over it, I am able to see the net name and the physical name. Clicking on it, we open the properties panel. We see the physical name, which is the name on the PCB, and the net name, which is the logical name on the schematic itself. If we have certain nets like a power net or a high-speed net, you can put additional information there for them. If I want to change the color, I can use this option and change the color as need be. If you have a more complicated connection, like this FMU harness, I can click it, Alt-click, and I am able to see all of the associated connections here. If I want to see if this type of harness or connection in general is connecting to another sheet, I can Alt double click and we get a navigable schematic tree here. I'm going to navigate over to this other schematic sheet. And once again, all connections associated with FMU are shown here. You can see everything has been dimmed out, so it's very easy to actually see everything connected to it. If I hold Control and Alt at the same time, I get that same type of tree dialog here. So once again, I go to FMU and I can see the different places I can navigate through. And that's going to make it really easy to navigate between connections on the sheets and understand the connections. From here, I want to change it up a little bit. I have the generic components here. They can be seen in the all category. So I'm going to place a resistor here. I'm going to click on it to open up its properties. And we have different parameters here that we can fill out. In this case, I'm going to fill out the value parameter, and I'm going to set it to 1K. And I'm going to copy this a couple times. And paste it. Okay, So from here, there is a way to annotate. So I'm just going to do that quickly, quietly annotate it. It'll give me some reference designators for that. So there's two ways to make changes to these generic components after you have finished up your design. I can replace an individual component in the properties panel with the under design item ID. If I click here, I get the pop-up to replace a component. But when you have several components that have the same type of information, we can also come through the active BOM document and see all of the components. Here we see there's no manufacturer part number. So now I want to change this. I go to operations, change resistor. I want to find an actual part that can be manufactured. I can acquire from a manufacturer. I have several options here. You'll notice that it takes the parametric values I have set and filters for them. So in this case, I just put 1K, but if I fill in more parameters, it will also filter by that. If I do control click and I select multiple components, I can compare them to make a better selection choice. Red are differing parameters and white are the same. In this case, I see there are a lot, the stock is much greater for this top component. So I'm going to select it and I get an ECO that to replace the parameters that are being taken from that component definition. I execute it and I come back over and we see that the components have their parametric information filled out. We have everything here. We also have the footprint, 2D and 3D. So we're able to just lay out whatever we need with these generic components, test out our circuitry, and then replace it with a known component at a later time. The last thing for this, I want to show going back to the components panel. I'm going to place this component. I'm going to place a couple. So you'll notice here that you have 2 pins, but you have 2 numbers here. That means that that pin is mapping up to different pads on the footprints. So if I click in to the properties of this component, I can see that there are a couple options for footprints. So if I go through and change it to the other footprints we have, we can see that each one is providing a different type of pin mapping, different direction of pin mapping. And you can see if we come down to the data sheet opened on the other monitor. We come down to the data sheet and we can see that that is because of this. Each one has a different type of connection. Therefore, we can use one symbol and map it to the different footprints in order to get effectively different components here, different configurations of the same component. For our final demonstration, we're going to come back to this Comet FMU project and right-click on the project name and select History. This is going to bring up our progressive timeline of events. You can see all the different commits of the project here. The automatically calculated differences are shown underneath the comment for the commit. You see here addition, removal, modification of all of these different design objects. For example, we see components here. I can search through them. Let's say I want to know when a component has been changed in my design. Here I put C2, and we could see all of the components that have C2 within their reference designator. This will also work for file names, net information, anything that is being covered in the automatic differences can be searched here. As you can see, also the comments are being searched through. If I go to any individual event and click on these options, I can open up a snapshot of the entire design, or I could revert to that snapshot. So the entire project will change back to this snapshot. We have the release here, all of the associated files with this. You can open the snapshot, compare Gerber files between revisions. I mentioned earlier that the comparison functionality is under development and will continue to grow. So currently you can compare Gerbers, and in the future you'll be able to compare more design information. In the web UI, you also have an ability to clone projects and download the project files themselves. This is going to allow managers, manufacturing, people who don't actually use Altium Designer to interact with the files in, a native environment on the web UI, and they can access it from anywhere at any time. Coming back to the projects panel, we have a couple new icons to introduce. Right here, we see for this file, power schematic, it says open, and Vincent Mazer is editing. As I open the file, I can see Vince here in the corner. I can see that he's editing the design. If I ignore that and I try and make a change, I am warned once again. I can abort the changes, or I could ignore the lock and continue with my changes. So in this case, I'm just going to abort changes, and I'll be able to see the schematic again. If, let's say, I ignored the lock and I continued to make changes, when I save, the VCS system would notify Vince and any other users that change has been made by me. There are another couple icons to show for this. Of course, it's a little bit difficult because you need multiple users to be interacting with everything. But I would say this is the most critical one to understand. The last thing we're going to look at is the comments panel. So we have the comments panel here. This has been updated pretty significantly. If you've used comments in the past, this comment panel now includes an addition to place a component directly on the schematic from the comments panel itself. So if I click place a comment, you can see here I can select any design object, and if I click and drag, it will add a comment for the area itself. We see here we have one comment here associated directly to this design object. Let's say that some change occurs with this object. Whenever you make a comment, a snapshot of the original design is included to ensure that your communication is in the context of the design, right? In case any changes have been made, you are guaranteed to have the original snapshot. So we see here, I tagged Chris, and he got back over to me. Over here, we have filtering options. Let's start with the visibility. So you can hide the visibility of these objects here. You see right here, the visibility changes. Let's say you have a lot of comments on your design. You can just quickly toggle that so that you don't have an issue. The filter options, I can remove all resolved comments. If I undo it, you could see a resolved comment here. I had assigned this comment to Arthur, and he resolved it for me. This is going to give us traceability of changes and actions and just overall feedback on a design. You could also filter by current documents. You can filter from, so I could say, who did, I need to see all the comments from Chris, and I can just select that right there and get that information.
Oke, tampaknya kita sudah di sesi akhir untuk webinar ini. Terima kasih atas attendance-nya. Untuk pertanyaan dan saran dapat di-emailkan ke sales@solidbasetech.com, atau misalkan nanti ada kendala di penggunaan Altium juga bisa di-emailkan ke sana. Oke, kita tunggu kehadirannya di webinar selanjutnya yang akan tentunya lebih menarik ya. Di webinar selanjutnya itu bulan depan kita akan ada topik tentang tips dan trik bagaimana melakukan desain di Altium. Jadi ketika kita membuat skematik atau membuat komponen, terus kita ke PCB-nya, itu kita akan memberitahukan banyak tips dan triknya di sana. Terima kasih, selamat siang.